Good evening. My name is Pinaki Satpathy from AC department, and today my topic is 8085 microprocessor. Before we just proceed to the microprocessor, first we should know what we mean by computer. What is a computer? Computer is basically a system which processes the information. The information to be processed is basically provided by the user. There are basically two types of information. One is analog information and another one is basically known as the digital information. Then what is analog information? Analog information varies linearly with respect to the time. It is continuous in nature. For example, sine wave, triangular wave, etc. is basically the example of our analog information. Next is digital information. This information consists of only two states, that is low state and high state. For example, square wave. There are basically two types of computers are there. One is analog computer, another one is known as your digital computer. What is an analog computer? Analog computer basically processes the analog information. It contains op-amp, diode, transistor, resistor, etc. It performs all mathematical operations such as addition, subtraction, integration, differentiation, etc. The result provided by the by this computer is not accurate. It depends upon the circuit parameters such as offset voltage, bias current, etc. Next one is what is a digital computer? It processes digital information. It contains logic gates, flip-flops, registers, etc. It performs ALU operation. ALU means basically arithmetic and logical operations such as addition, subtractions, etc. And logical operations such as AND, XOR, etc. The result provided by this computer is accurate. Because the result does not depend upon the circuit parameters, the size of this computer is very small as compared to the analog computer. There are basically three types of digital computers are there. One is mainframe computer. It consists of two or more central processing units. Each CPU is implemented by using two or more chips. The data storage capacity of this computer is very large. The word length is more than 64 bit. It has high speed. It is used for complex scientific calculation, complex graphical calculations, military defense applications, space program applications, etc. Next one is mini computer, second one. It consists of only one CPU unit. This unit consists of two or more chips. The data storage capacity of this computer is moderate. The word length varies from 32 to 64 bit. It has moderate speed. It is used for simple scientific calculations, industrial process control, etc. Next one is microcomputer. It consists of only one CPU unit. This unit consists of single chip. This single chip is basically known as our microprocessor. The data storage capacity of this computer is less. The word length varies from 8 bit to 64 bit. It has low speed. It is used for personal computer. Next is simple industrial process control. Basically, we are having three types of microprocessor. One is known as 8-bit microprocessor. Next one is 16-bit microprocessor. Next one is 32-bit microprocessor. And another one is basically 64-bit microprocessor. 8-bit microprocessor is basically the width of data bus is 8-bit. The different types are Intel 8068, 808, 8085, then Z80, MC6800, etc. Next one is 16-bit microprocessor. In this, the width of the data bus is basically of 16-bit. The different types are Intel 8086, 8088, 80186, 80286, 8, then MC68, 000, etc. Then 32-bit microprocessor. In this, the width of the data bus is basically 32-bit. The different types are Intel 80386, 80486, etc. Next one is a 64-bit microprocessor. In this, the width of data bus is 64-bit. The example is Intel Pentium processor. So today we'll basically discuss about our 8085 microprocessor. This is basically a 8-bit microprocessor. Then what are basically the features of our 8085 microprocessor? Basically our 8085 microprocessor is basically a 8-bit microprocessor. 8085 microprocessor can read or write or perform arithmetic and logical operations on 8-bit data at a time. In 8085 microprocessor, we are having basically 8 data bus and 16 address bus. So the total memory size of 8085 microprocessor is 2 to the power 16 should be equals to 64 kilobyte of memory. Then the clock frequency used for our 8085 microprocessor is basically 3 megahertz. It basically requires plus 5 volt DC power supply to operate. It is a single chip NMOS device implemented with 6200 transistors. It provides 74 instructions with 5 addressing modes. It provides 5 hardware interrupt and 8 software interrupt. Our next topic is that is the functional block diagram of 8085 microprocessor. This is basically the functional. This is basically the functional block diagram of 8085 microprocessor. If we see, it is having our first block is that is a accumulator. What is a accumulator? Accumulator is basically a 8-bit register. During some arithmetic and logical operations, one data is placed in our accumulator. After the ALU operation, the result is placed in the accumulator. Next one is our general purpose register. There are basically 6 general purpose registers are there in 8085 microprocessor. The general purpose, they are basically denoted by B, C, D, E, H and L register. The width of each register is basically 8-bit and hence it is used to store 8-bit data. If we want to store 16-bit data, then the following register pairs are used: BC pair, DE pair and HL register pair. Next one is our temporary register. It is basically a 8-bit register used by the microprocessor. It is not accessible by the programmer. Next one is our temporary register. Temporary register pair, it is basically a 16-bit register. It is used by microprocessor to store 16-bit address temporarily. It is not accessible to the programmer. Our next one is basically our program counter. Program counter is what? It is basically a 16-bit register. Initially, it stores starting address of the program which is stored in the memory. Once the execution of program begins, the program counter gets incremented one by one usually, but some special instructions like call, then JNG means jump if not 0, can change the content of program counter to any value. Next one is our stack pointer. Next one is our stack pointer. Uh, what is basically the stack pointer? It is basically a 16-bit register. It stores the address of the stack. It points the stack. During push operation, stack pointer is decremented. During pop operation, stack pointer is basically incremented. Stack is some part of memory which is used for temporary storage of the microprocessor. It functions on LIFO basis. LIFO means last in first out basis, or FILO basis, that is first in last out basis. Next one is our instruction register. That is this block, that is instruction register. It is a 8-bit register. It is used to store the opcode which is fetched from the memory. The next one is our instruction decoder. It decodes the opcode which is fetched from memory and gives instruction to timing and control in what way to execute that particular instruction. Next one is our timing and control block. This section includes one oscillator and a sequence controller. It synchronizes all registers and generates the control signals needed for internal and external control until the instruction is executed. Next one is our address buffer and data address buffer. They are used to isolate microprocessor's internal bus from external bus. They are used to drive external address bus and external data bus. Memory chips and input-output chips are connected to these buses. When not in use, output of buffers are in open state, that is they have in stride state. Next one is arithmetic and Logic unit block, this particular block, this unit performs arithmetic operations such as addition, subtraction, multiplication, increment, decrement, and logical operations such as logical and logical or XOR. So this kind of operation is basically being performed. Next one is our flag register. In case of our 8085 microprocessor, there are basically 5 flags are used. The 5 flags are denoted by sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. Just 1 second. This is basically the whatever I just told about the flag register, and that is accumulator. Whatever the general purpose register I have told, that is BCDHL register pair, all these things. Yeah. So this is basically the structure of our flag register, whatever I'm just talking about. In case of our flag register, there are basically whatever I've just told, that is 5 flags are there, that is sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. So first one is sign flag. What is basically a sign flag? In case of our 8085 microprocessor, whatever the size of our flag register, that is basically a 8 bit. So what is a sign flag? This flag is set if this flag is basically being set if MSB of the result of an arithmetic or logical operation is equal to 1, otherwise it is reset to 0. Next one is our zero flag. This flag is set if the result of arithmetic or logical operation is equal to 0, otherwise it is basically being reset. Next one is our auxiliary carry flag. This flag is set when there is an overflow from the fourth LSB during the execution of arithmetic operation. Otherwise, it is basically been reset. It is mainly used in BCD arithmetic. BCD means that is binary coded decimal arithmetic operation. Next one is our parity flag. What is parity flag? Now, this flag is basically being set if the result of arithmetic or logical operation contains even number of ones, otherwise it is basically being reset. Next one is carry flag. What is carry flag? Now, this flag is set if there is an overflow from the MSB after the execution of arithmetic operation. Next is our Next is our that is serial input output control block. This particular block, it is used to send data from input device serially bit by bit into the microprocessor or give data to the output device serially bit by bit from the microprocessor. Then next one is our incremental and decremental address latch. That is incremental and decremental address latch. It is used to increment or decrement the content of program counter or the stack pointer. Next one is interrupt control block. Then the question comes in our mind, what is basically an interrupt? Interrupt is what? Now, interrupt is basically a request to the processor for immediate execution of the same routine. In case of our 8085 microprocessor, there are basically, if you see here, that is trap, RST 7.5, RST 6.5, RST 5.5, and INTR. So these are basically the interrupt signals is basically being used in case of our 8085 microprocessor. Among those, trap is having the highest priority, then the priority comes in the basis of RST 7.5, 6.5, 5.5, and then INTR. INTA bar is basically known as an interrupt acknowledgement, that is not basically an interrupt signal. And among those, this particular interrupt, trap is basically known as a non-maskable interrupt, and whatever our other basically known as our maskable interrupt. So this is all about our basically the functional block diagram part. Next one. Next one is basically the pin diagram of our 8085 microprocessor. Okay. Pin diagram of 8085 microprocessor. All the signals of 8085 microprocessor can be basically classified into our 6 groups. We have to classify it. First one is known as our address bus. Next one is known as our address and data bus. Next one is control and status signals, then power supply and frequency initiated signals, and then interrupts and peripheral initiated signals, and next one is serial input output ports. So first one is address bus. If you see here, that is address bus is basically of basically A8 to A15, that is A8 to A15. They are basically used to carry our higher byte address, and they are basically known as unidirectional. Next one is our address and data bus, that is from AD0 to AD7. If you see here, that is the things. They are basically used to carry the lower byte address as well as data. They are basically bidirectional. They are basically bidirectional. Next one is control and status signals. Within that control and status signals, our first signal is that is known as ALE signal, that is known as address latch enable signal. It is the output signal from the microprocessor. When this signal is high, AD0 to AD7 basically carry lower byte address. When it is low, then AD0 to AD7 basically carries our data part. Next one is our RD bar, that is read signal. It is the output signal from the microprocessor. When it goes low, read operation takes place, and when it is go high, at that time no read operation will be performed. Next one is WR bar, that is known as write signal. It is the output signal from the microprocessor. When it goes low, write operation basically being takes place, and when it is high, no write action will be takes place. Next one is IO/M bar signal, that is input output and memory read signal. It is a output signal from the microprocessor. When it goes low, memory action takes place, and when it is goes high, input output operation will be basically being take place. Next, we are having two status signal, that is known as one is S1, another one is known as our S0. So these two status signal is basically being used, that is S1 and S0. So what is the function of these two status signal? When S1 and S0 both will be equals to 00, at that time halt operation will be performed, and whenever S1 equals to 0 and S0 equals to 1, at that time write operation will be performed. When S1 equals to 1, S0 equals to 0, at that time read operation will be performed, and whenever S1 and S0 both will be equals to 1, 1, at that time opcode fetch operation will be performed. The status of this signal indicates what type of operation is performed by the microprocessor. Various types of operation are shown in this particular thing. Next one is our power supply and frequency initiated signal. So within that first power supply is that is VCC. It is basically been connected to plus 5 volt power supply. Next is VSS, that is ground. Okay, that is VSS, that is basically our connected to the ground potential. Next is X1 and X2. Across these pins, crystal is connected to provide the oscillation of the fixed frequency. The system frequency is half of the crystal frequency. If we want the system frequency equals to 3.125 megahertz, so at that time the crystal frequency must be equals to 6.25 megahertz. Next one is our clock out signal. This is basically our clock out signal. If you see here, that is our clock out signal within that. Okay, it is basically used as system clock for the other devices. This frequency is same as the system frequency. Next is interrupt and frequency initiated signal. Within that, the first signal is our ready signal. Within the first signal is our basically our ready signal. This is basically the ready signal. What is the function of our ready signal? Now, it is the input signal coming to the microprocessor. Some peripheral devices are very slow and they are unable to follow the speed of the microprocessor. To just slow out the speed of the microprocessor, this particular signal is basically being used. If the peripheral device is not ready for data transfer, then this signal goes low, and so no data transfer will be possible. Now microprocessor will be in wait state. Next one is reset in signal. What is the function of our reset in signal? It is the input signal provided to the microprocessor. When it goes low, then the program counter is reset to 0000 and buses are tri-stated. Next one is reset out signal. Reset out, it is basically the output signal from the microprocessor. When it goes high, it indicates microprocessor is being reset. This signal can be used to reset the other devices. Next one is hold and HLDA pin. Hold is basically the input signal provided to the microprocessor when it goes high. DMA controller, that is known as direct memory access controller, indicates to the microprocessor to release the control over the buses so that peripheral device can access memory directly during the DMA operation. Next one is HLDA, that is hold acknowledgement. It is the output signal from the microprocessor. When it goes high, microprocessor indicates DMA controller that it releases the control over the buses. Now, peripheral device can use these buses to access memory directly during the DMA operation. Next, we are having the interrupt signal, that is trap, RST 7.5, 6.5, 5.5 and INTR. As I just told earlier, what is an interrupt? Interrupt is basically a request to the processor for the immediate execution of the same task or same routine. There are all input signals to the microprocessor. When this signal goes high, microprocessor is interrupted. Now, microprocessor executes current instruction and stores the address of the next instruction into the stack pointed by the stack pointer. Then control is transferred to particular memory location. Then microprocessor executes subroutine present at that particular location. After that, the control will be back to the main program by popping the address from the stack pointed by the stack pointer. In this, trap has having the highest priority and then followed by RST 7.5, 6.5, 5.5 and then INTR. Next is INTA bar, that is known as interrupt acknowledgement. It is basically the output signal from the microprocessor. When it goes low, microprocessor acknowledges the arrival of the interrupt. Next is serial input output ports. Within that we are having SID and SOD pin, that is serial input data and serial output data. By using this, data can enter serially bit by bit into the microprocessor from the input device. And next one is SOD, that is known as serial output data. By using this, data can come out from microprocessor serially, that is bit by bit, to the output device. So this is all about the functional block diagram and basically the pin configuration of 8085 microprocessor.